Welcome to the journey of exploring IoT technologies, a connected world. Content of this media is what is IoT, history of IoT, IoT ecosystems, IoT platforms, IoT protocols, IoT gateways, IoT security, IoT standards, IoT devices and applications, and lastly, IoT future trends. What is IoT? IoT stands for the Internet of Things, which refers to a network of interconnected physical devices, vehicles, buildings, and other objects embedded with sensors, software, and network connectivity, enabling them to collect and exchange data. For example, think of a smart thermostat in your home. It can sense the temperature, connect to the internet, and be controlled remotely from your smartphone. In simple terms, IoT is about making our things smart and connected to make our lives easier, more efficient, and more convenient. Significance of IoT in our daily lives. IoT has become an integral part of our daily lives, impacting various aspects such as healthcare, transportation, and smart homes. It enhances convenience, efficiency, and safety in these areas. Evolution of IoT. Machine to machine communication. IoT's roots can be tracked back to the concept of M2M communication, where devices communicated with each other without human intervention. This technology began to take shape in the 20th century primarily for industrial and logistical purposes. IoT emergences. IoT evolved from M2M with the integration of the internet and cloud computing. This evolution allowed devices to not only communicate with each other but also with centralized systems, leading to the birth of the Internet of Things. Here are few key milestones in IoT development. In 1999, first time we heard the term Internet of Things. And the first international conference on the Internet of Things was held in 2011. Let's talk about IoT ecosystems. Overview of the IoT ecosystem components. The IoT ecosystem is composed of several key components that work together to enable the functioning of IoT devices and systems. These components include sensors and actuators, connectivity, data processing, user interface. Sensors. Sensors are the devices that collect data from the physical world such as temperature, humidity, or motion. Common sensors include temperature sensors, motion detectors, humidity sensors, and light sensors. Actuators. Actuators, on the other hand, are the responsible for carrying out actions in response to sensor data. They are crucial in making IoT devices interactive. Examples include motors, solenoids, and relays. Connectivity. Connectivity refers to the means by which IoT devices transmit data to the cloud or the other devices. There are two types of connectivity technologies: wireless technologies and wired technologies. IoT devices often use wireless communication protocols like Wi-Fi, Bluetooth to connect to the internet or other devices. Wired technologies. Ethernet and power over Ethernet are used in some industrial IoT application. It's not commonly used. Data processing. Data processing involves the storage, analysis, and interpretation of data collected by sensors. This is often done in cloud or at the edge to derive meaningful insights and facilitate real-time decision making. Edge computing. Edge computing is a decentralized approach to data processing, where data is processed closer to the data source, typically at or near the edge of the network, rather than the centralized data center or the cloud. Other methods of data processing: fog computing and cloud computing. Fog computing. Fog computing is a model that extends cloud computing capabilities to the edge of the network, often using edge devices or gateways. Cloud computing. While not as immediate as edge or fog computing, cloud computing is essential for storing and processing large volumes of IoT data over time. Other component of IoT ecosystem is user interface. The user interface is the point of interaction between users and IoT devices. It can be a mobile app, a web dashboard, or other interfaces that allow users to monitor and control connected devices. IoT platforms. IoT platforms provide tools and services for device management, data processing, and application development. They act as a bridge between IoT devices and applications, providing essential functionalities to make IoT development more efficient. Examples include AWS IoT, Google IoT, and Microsoft Azure IoT. Key functions of IoT platforms: device management, ingestion, data processing, connectivity management, security, application enablement, integration, analytics. IoT protocols. IoT devices use specific communication protocols to transmit data efficiently and securely. IoT protocols are communication standards that enables devices and applications to exchange data in the Internet of Things. These protocols ensure efficient and secure data transfer between IoT devices and the cloud or other devices. Key IoT protocols: message queuing telemetry transport, constrained application protocol, HTTP, HTTPS, that means hypertext transfer protocol, widely used for web communication and commonly used for IoT dashboards and APIs. The fourth one is advanced message queuing protocol, COAP. The sixth one is Bluetooth. The seventh one is long range wide area network. Eighth one is IPv6 over low power wireless personal area networks. Those are the key IoT protocols. Let's talk about IoT gateways. IoT gateways are essential components in the Internet of Things ecosystem that bridge the gap between IoT devices and the cloud or the central server. It facilitates data aggregation, pre-processing, and secure transmission, enhancing the efficiency and reliability of IoT ecosystems. Key functions: data aggregation, pre-processing, security, protocol translation, local storage, and remote monitoring and control. Benefits of IoT gateways: improved efficiency, enhanced security, real-time processing, and scalability. IoT security challenges. IoT security is crucial due to the potential vulnerabilities of connected devices. Security measures include device authentication, encryption, and regular software updates. Security concerns and vulnerabilities. IoT devices are susceptible to various security challenges, including weak authentication, inadequate encryption, and insufficient security update mechanisms. Vulnerabilities in IoT devices can be exploited for data breaches, unauthorized access, and even device manipulation. Strategies and technologies to enhance IoT security: implement device authentication, encryption, secure network, auditing and monitoring, education. IoT standards, standardization bodies and organization. Various standardization bodies and organizations are actively working to establish common standards for IoT, ensuring interoperability and security. The ability of devices from different manufacturers to work together seamlessly is a key outcome of these standards. Standardization bodies and organization, Open Connectivity Foundation, and IoT devices and applications. These devices are building blocks of the Internet of Things and have diverse applications across various industries. IoT devices are physical objects embedded with sensors, connectivity, and software to collect and exchange data. Smart home devices, wearables, industrial IoT applications are examples of IoT devices. Impact and benefits. IoT devices have transformed our lives by making homes smarter, promoting well being, and revolutionizing industries. Emerging trends in IoT technologies: 5G integration, AI and ML advancement, edge computing expansion, IoT in healthcare and telemedicine, sustainable IoT, blockchain for IoT are the most emerging trends in IoT technology. Thank you. Thank you for joining us on this journey through the dynamic world of IoT as we embrace these innovation trends, and we look forward to a future where IoT continues to enhance our lives, shape our